Okay, so on question 1, we are going to ask about a rate. And what a rate is how much per one of something. Okay, so when I compare this, we're talking about the price of cheese. So tell me what makes more sense to you in real life. Do I want to know how many kilograms per $1, or do I want to know how many dollars per 1 kilogram? Which one makes more sense at a store? The kilograms per dollar or the dollars per kilogram? Which one in real life would make more sense? Probably the price per kilogram. What price per kilogram? Have you guys been to a store and ever actually looked at a price when it's really close? You can usually see on the bottom, they actually do that for you. So you don't have to calculate it. They'll write down, this is the cost per whatever it be, milliliter or kilogram or gram or whatever. Okay, so at store A, they had $68 for 8 kilograms. I want to know how much dollars for 1 kilogram. Okay, does this look like anything we know how to do? Do we have a strategy to solve something that looks like that? It's called multiply, divide, cross multiply. So I need to go this divided by that, right? So 68 times 1, which you don't really even need to type, divided by 8 is going to be $8.50 per kilogram. Okay, so then what are we going to compare it to at store B? It was $88.20 for 12 kilograms. So what is going to be the unit price? So what per 1 kilogram? How much would it cost you for 1 kilogram there? Okay, so this is called the unit rate. And then I can now conclude what? Where should we shop or what's cheaper, right? So store B is cheaper. Okay, so then we're going to do question B, which compares some gas prices. So again, you should always ask yourself what makes more sense in life. Does it make sense to say how many liters per $1 or how many dollars per 1 liter? What would make sense in life? How much dollars per 1 liter would be the unit rate we would look for. So then $41.36 for 44 liters is what unit rate? This is called the unit rate. So I'm going to let you finish this question out and see if we can compare the unit rates. Okay, how are we looking? I got a 94 cents per liter, and I got a 98 cents per liter. Don't you wish gas was that cheap? So then I would conclude on my test now, I can say, well, A is cheaper because I've compared them per unit rate. Okay, so now let's look at rates using a graph. Okay, so I'm gonna call these intervals. So let's go section A, B, C, D, and E. Let's make those little sections. Okay, here we go. From A, I started at 0 meters and I went to what? Should we say that is exactly 10 meters? So I did 10 meters over what? How many seconds would be there? I don't know. I don't think we're lined up with 10. What do you guys think? 9? So I have moved 10 meters over a span of 9 seconds. So my unit rate is a velocity, that's a speed, 1.11 meters per second. Okay, so what's the height on this one? What do you want to say? I don't know. 14, anybody? Something like that? Is that good? So the height of this is 14. Okay, but I'm not going to use 14. How many meters have I moved? What did we say A was? You were already 10 meters. So now you're at 14 meters. So how much have you moved? You've only moved 4 meters because you were already at 10. Now you're at 14. So from here to here, I've only moved 4 meters. How much time have you moved? So remember we put this at 9 seconds. What are you going to put B on top of? How many seconds? What does it line up with? What do you want to do? 17, 18? 18? So if we line it up with 18, how many seconds have we traveled in that section? 9 seconds. Because we were at 9 seconds and now we're at 18 seconds. So we are okay, so that's your velocity, which is your rate, 0.44 meters per second. Okay, so let's do the next section, C. Are we going to agree that we are at 30? Should we just say we're at 30 there? So how many meters have I moved? Remember, we actually started at 14 and now we're at 30. So we were at 14 and now we're at 30. So how much have we moved? Did you write 16 meters? And then how much time have I done in that section? What are you going to line that point up with? Anybody find a good number here? Is it like 20 or 21? Anybody? Better eyes than me? Should we do a 21? Okay, so how many seconds have I passed in that time? We were at, the last time we said we were at 18, so 21. So if I go from 18 to 21, I have passed 3 seconds. Okay, section D. How many meters did you move? In section D, we were at 30 meters, and at the end of this section, we're also at 30 meters. So how much meters did we move? 0. We didn't move at all. We said 21 seconds for this one. What is the number on top of this one? 30 seconds? 21 seconds. Should we go to 30 seconds for that point? So if we've moved 0 meters over the 9 seconds in that section, what is 0 divided by anything? 0. Okay, from E, start of E to the end of E, how many meters have you moved? You were at 30 here and now you're at 0. So how many meters did you travel? Minus 30. Minus 30 meters, right? Because you were at 30, now you're at 0, so we actually went down 30 meters. And how much time passed in that section? How much do you want to say? We put this one on top of 30, and you want to say that's at like 32 seconds or something? 2 seconds. Okay, so that's how you find a unit rate. You have to take each little section and say how much meters I've moved, how much seconds I've moved. And you have to understand in each little section. Okay, which section are we going the slowest speed? Okay, let's not put the 0 in this. Obviously 0 is the slowest, but not putting 0 in. Which one of them is the slowest? Probably B, right? That's the lowest number. Which interval was the fastest? Which has the biggest number? Section E. That was the biggest number. 15, bigger than a 5. Okay, doesn't matter that it's negative. Okay, negative is just something else we're going to get to. Tell me how I could have answered those questions without these numbers. Just looking. What tells me something is fast or slow on a graph? Let me understand slopes from grade 10. Graphing slopes. When you look at that on a graph, this is barely going up, and this is really going up. So this is steep, and give me a word. I'm not an English person. What's the opposite of being steep? Flatter? Anybody have a better word? I don't know. Flatter, steeper. So in a slope sense, this is less and this is more. Do you remember slopes from graphing lines? Slopes, okay? Does that make sense though? Why something would be slower or faster? When does the ATV start returning home? When would it start doing that? Right here, it's going to start to go back, right? So we answer at 30 seconds. Remember, we put that on top of 30 seconds. So this is the time where we start to go home. When does it get home? When did it actually get back? Right? This point is when it's back home. So I would answer 32 seconds it got home. What does a slope of 0 mean in this context? So a slope of 0 was in our section D. When we did our math, section D had a slope of 0. So this was the slope of 0 in section D. That was the slope of 0. What does it mean? You're driving a quad. What's happening if your distance was 30 meters and then it was 30 meters? What did you do? You didn't move. So you were you stopped, right? You just stopped somewhere and you didn't travel. So that's what a slope of 0 means. Okay, I want to do maybe another problem with you here. Okay, can you flip to this one? Is that in a spot? Can you like turn one page, I think? 7.2. Okay, Isaac is training for a half marathon. So a half marathon is 21.1 kilometers, and he can run this in 2.25 hours. So what is his speed per hour? Okay, so he can, what do we want to put on top and bottom? Do we want to be doing kilometer per hour stuff or hours per kilometer when you do a speed? What makes more sense to your brain? Kilometers per hour or hours per kilometer? Kilometers per hour, right? Kilometers per hour makes more sense. This is real world context. So we were doing 21.1 kilometers in 2.25 hours. How many kilometers per 1 hour? That's a speed. That's a unit rate of your speed. Okay, so there's my speed, my unit rate. Mike needs to order snacks for a meeting and there's 170 people. He decides to order donuts, which comes in a box of 12. He estimates that each person is going to eat 1.5 donuts. So how many boxes should he buy? Okay, so here's what I know. One person equals 1.5 donuts. That's what I know. That's how much we're estimating each is going to eat. So what do you think I'm going to do? 170 people. How much donuts are we going to eat? That's what I want to know. Does this make sense? One person equals this many donuts, so how much does 170 people make? So do you see how I always have to line up when I'm cross multiplying stuff? I always have to make sure everything's in a proportion. When I say that, you can't put people and donuts and then donut and people. You can't mix and match. Cross multiply. Are we good? I'm going to have to buy 255 donuts. Now part 2. How many boxes of donuts do you need to buy then? What are we going to do to figure that out? Okay, so we could do another proportion. 255 donuts equals how many boxes? What do you know? What do you know about donuts and boxes? 12 donuts in one box. So you're always with proportions, you write what do I want to know proportion and what do I have proportion. So this is what I want, this is what I have. So times divide. I'm not going to answer like that. Have you ever gone to a store and said, can I have 21.25 boxes of something? Okay, so we're going to go to a whole number. What would you do if you were ordering these? Would you want to round to 21, or should we just buy 22 boxes? Because it's better to have leftovers than be short, right? So I'm just going to go, hey, in life, it just makes more sense to order up so that you're not short. Okay, last one of the day. Okay, so Carla is defrosting meat in the microwave, and then it's given a mass in kilograms. And then she Googled, and it says it takes 20 minutes to defrost 3 pounds of meat. So how long will it take her to defrost? So this question has us all confused because we have something in kilograms, but then there's pounds. So what we're going to do is we're going to convert. So I'm going to go like this. 4.23 kilograms is how many pounds? That's what I want to know. Can you write me a matching proportion about what you do know? Because I gave you that in brackets. So what did I tell you as a conversion? 1 kilogram is 2.2 pounds. So I can cross multiply because I have it all set up perfectly with kilograms and pounds. Okay, so I have this many pounds of meat. Part 2. This many pounds of meat is going to be how many minutes? If I have that many pounds, how many minutes will I go? That's what I want. And then what's the thing you know? Google says it takes 20 minutes to do 3 pounds. 20 minutes to do 3 pounds. Make sure you have it lined up. Proportions, do you see? Pounds, pounds, minutes, minutes, always lined up together. I'm just going to go to a whole number on this one. So 62 minutes of time. Here's your final answer. Okay, super quick. Do you guys know how to convert like time between minutes and hours? That's a tough thing. So 40 minutes is not 0.4 hours. That's what I get as a mistake. What do? It's not 0.4 of an hour. That's not what it is. So what should you do instead? 60 minutes is equivalent to 1 hour. So if you had to do a decimal, it'd be 0.67 of an hour, okay? So what if I told you 1 hour and 18 minutes? What would you do with something like that? Well, I know what that's all about, so scrap that for a second. And then I would change that to hours. So dividing by 60, right? And lots of you don't have to write these proportions. If you understand, just divide by 60. So that's 0.3, so 1.3 hours. Okay, so just be careful with time because it's not using decimals with tenths. It's using 60th, so it's like everything's weird. And then I could give you like this, 1.6 hours. What? How many minutes is that? So what do? How many minutes is it? Okay? Or I might say, how many hours, comma, minutes? I might do something like that. So what is 96 minutes? How many hours? 1 hour. So you had 1 hour there. How many extra minutes do you have past the hour? What would you do? Minus 60 from it. Okay? I don't really have a lot in our notes because I was hoping it'd be a little bit of common sense with how that works. It's not just decimals, making sure you understand minutes and hours there.